Hi guys, my name is Anacan from STM17 and this video is all about chain rule, optimization, and related rates. In this video presentation will be my final exam. Let's get started, let's go! Our first problem is all about chain rule. It is f of x 2 raised to sine 4x. First, we need to find the derivative of the given function. It is a derivative of f of x equals d over dx, 2 raised to sine 4x. The second step was we need to use the differentiation rules. It is a derivative of f of x equals d over dg times 2 raised to g times d over dx times sine 4x. The third step is calculate the derivatives. It is the derivative f of x equals ln times 2 multiplied to 2 raised to g times cos 4x times 4. The fourth step is substitute back the values. It is the derivative of f of x equals ln times 2 times 2 raised to sine 4x times cos times 4x times 4. The final step for this problem is simplifying the answer. Our final answer is the derivative of f of x equals ln times 2 raised to sine 4x plus 2 multiply to cos times 4x. And our next problem is all about optimization. We have this given: a farmer wants to fence an area of 1.5 million square feet in rectangular field and then divide it in half with the fence parallel to one of the sides of rectangle. How can he do this so as to minimize the cost of the fence? Our first step will be draw a picture of the scenario that is described. The upper and lower part of rectangle is x. The side in the center of a rectangle is y. We're now going to the constraint equation. To find the area, we need to use the equation A equals length times width. The length of a rectangle is x. The width of a rectangle is y. To find the constraint equation, we need to divide both sides with x. And the right hand side, that x's will be cancelled out. Now, we're going to the objective equation. The perimeter is equal to 2x plus 3y. And now, we're going to substitute value of y to the objective equation. P equals 2x plus 3 bracket 1.5 times 10 raised to 6 over x bracket. Multiply the numerator to the x and multiply the x to the 1. And our answer will be P equals 2x plus 4.5x times 10 raised to 6 over x. In order to find the value of the perimeter and hence the minimum cost, we need to compute the derivative. Take the x denominator and move it to the numerator. And the derivative of p prime is now 2 minus 4.5 times 10 raised to 6 x raised to negative 2. We're going the p prime to 0. So, our p prime is now 0 equals 2 minus 4.5 times 10 raised to 6 x raised to negative 2. And now we're solving for x. Multiply each term to x squared. So x squared times 0 equals 2 times x squared minus 4.5 times 10 raised to 6 x raised to negative 2 times x squared. So the answer will be 0 equals 2x squared minus 4.5x 10 raised to 6. Move the negative 4.5 times 10 raised to 6 to the right for it to become positive. So it will become 4.5 times 10 raised to 6 equals 2x squared. And now we're going to cancel the 2 in numerator and the 2 in our denominator. Then we will take the square root of the both sides of the equation. And it will be square root 2.25 times 10 raised to 6 equals square root of x squared. And the answer will be 1.5 times 10 raised to 3 equals to x. To confirm that this value of x is actually does indeed minimize the value of the perimeter and the hence of value of the cos fence. We were using the second derivative test. We're going to use the first derivative and it is 2 minus 4.5x 10 raised to 6 x raised to negative 2. And the second derivative of that was 0 plus 2 times 4.5x 10 raised to 6 x raised to negative 3. And the answer it will be 9x 10 raised to 6 x raised to negative 3. Move the x raised to negative 3 to the denominator. It will be 9x 10 raised to 6 over x raised to 3. Then we're going to use the value of x into our second derivative. Look at the numerator, and this is positive. And our denominator is also positive. In dividing positive over positive, we will get a positive number. In second derivative test, if we will get a positive result, we have a local minimum at x equals 1.5x 10 raised to 3. The second derivative test confirmed that our value of x does indeed minimize the cos of the fence. And now, we're going to solve for y. Y equals 1.5 times 10 raised to 6 over 1.5 times 10 raised to 3. And the answer will be 1.0 times 10 raised to 3 or 1 times 10 raised to 3. And our final answer for this problem is x equals 1.5 times 10 raised to 3 feet, and for y was y equals 1.0 times 10 raised to 3 feet or 1 times 10 raised to 3 feet. And now we're moving to our last problem. It's all about related rates. We have this given: a street light is mounted at the top of 15 feet tall pole. A man 6 feet tall walks away from the pole with a speed of 5 feet along a straight path. How fast it is tape of his shadow moving when he is 40 feet from the pole? Our first step will be showing some image on what the scenario described to us. The distance of the man from the lamppost, it will be our x, and let his shadow let be our y. Now, as man is moving away from the lamppost, x is a function of t and speed of man is dx over dt. Then, as they form similar triangle, we need to cross multiply the 15 over 15 minus 6 and the x plus y over x. And the answer will be 15x equals 9x plus 9y. Take the 9x and move it after the 15x, and it will be 15x minus 9x equals 9y. And we need to put some 9 over the 9y and 6x for us to be able to cancel the 9 in our numerator. And it will be 6x over 9 equals y. And we need to simplify the 6x over 9. And the answer will be 2 over 3x equals y. The shadow is x plus 2 over 3x equals 5 over 3x. The solution for that, we need to put 3 over the x and cross multiply it with 2 over 3x, and the answer will be 5 over 3x. When the man moves dx feet, shadow moves 5 over dx feet. The shadow moves with the speed of 5 dx over 3 dt. To get the final answer, we need to times the 5 over 3 to 5. That 5 is the seconds of the speed. So the answer will be 25 over 3 or 8.33 feet over seconds. That's all for my video presentation. I love you all. Sana may natutunan kayo, and thank you for watching. Stay safe and bye bye guys!